Good afternoon and welcome to our second Northern Powergrid Active Network Management webinar. My name is David Van Kesteren and I'm sat here today in our Castleford offices with Ian Fletcher, and together we're going to give you a presentation on where we are with Active Network Management, or ANM as I'm going to call it from now on, and what our plans are in terms of rollout elsewhere. So the format of today is we've got about 20 minutes of presentation to give to you. You are all in listening mode view, so you won't be able to actually actively contribute to the conversation, but there will be a couple of live polls where you can help us to understand a little bit more about what you understand already and what you are looking for, and also you'll be able to ask us questions at any point throughout the presentation. Now, as you ask the questions, we will mainly be answering them at the end of the presentation, but we'll be noting them down as we go through. If we do pick up some questions that we can answer in the flow of the presentation, we will do that, but obviously we're keen to get through the main material, so more likely we'll come back, but if we do spot one that's relevant and we can answer it at the time, we'll certainly do that. Also, after the webinar's finished, you can send any feedback or contributions or things you want to talk about to the email address there, ice@northernpowergrid.com. Also, we'll share with you some other ways that you can get in touch with us afterwards as well. So the presentation is going to consist of 6 key parts, and that is, we're going to start off with a brief refresh on what ANM is and how it works. We have given a previous number of presentations elsewhere and the previous webinar that went into a little bit more detail about what ANM is, but we're still just going to cover it off as a reminder, and if you don't know what it is, there'll be enough there to get you going. We're going to give you an update on our Driffield scheme that's currently in construction, and then the main purpose of today is really to let you know about our plans going forward, so how we're identifying other potential areas of constraint on the network and our rollout plans and costs associated with rolling out ANM elsewhere. And then just a little touch towards the end on demand side response and what that is and how that compares with and fits in with ANM going forwards. And then at the end there'll be plenty of time for you to ask questions and for us to go through with answers. So we are planning to have about 30 minutes for that, but we'll play that by ear, seeing based on the number of questions we get. So we're going to start now with a poll. It's a very simple one. We just want to get a feel really to help us of what experience you've already got of ANM. So we've got those three suggested responses there of that maybe you've heard of it but don't really know what it is, or you've got some general familiarity and you just want to learn a bit more, or actually you might have been involved in ANM connection inquiries with MPG or with other people, and we'd just like you, please, if you could just take a few seconds to give us an answer to that, and we'll wait for those answers to come through, and we'll share that back with you in a minute or so so you can see what the group's made up from as well. And then once we've done that, I will hand over to Ian, who will tell us a little bit about what ANM is and how we're getting on with the Driffield scheme. So we'll just give that another 10 or 15 seconds. I can see about half the people have responded so far. We'll just give it a little bit longer, see if anyone else can give us a quick response. While we're waiting, I'll introduce Ian. So welcome to Ian. I've not given you a chance to speak yet.
Yeah, hi folks. Welcome to the webinar today. As David says, I'll be providing a bit of an overview of the Driffield scheme and where we are with that. A little bit on what ANM is. So apologies to some of you people out there that might have watched the ANM webinar that we did last year. A couple of the slides might look a little bit familiar, but I think that they serve a good purpose in describing what ANM is and what it does for us on our network too. So
Okay, thanks for that, Ian. Okay, I'm going to bring the poll to an end now. You've got about 5 seconds left if you haven't responded yet. 3, 2, 1, time out. Okay, so I've got a button somewhere I can press, I believe, that allows you to see where that is. So in terms of mix, we've got a third of the audience are quite familiar with ANM concepts and want to learn more. We've got another quarter who have had direct dealings with some sort of connection inquiries across the UK, and the remaining 40% are just interested to know what it's about. So I think we'll be able to fulfil the needs of you all, and so we'll get cracking. I'll hand over to Ian, and we will start with a simple intro into what is ANM.
Yeah, okay. Hi, folks. So ANM's effectively a monitoring and control system that uses electricity distribution system information to constrain a customer's imports or exports to avoid overloading our network. It's primarily used in specific system areas where there's little or no system capacity available for a traditional cell connection that doesn't carry with it some costly reinforcement that may be chargeable to the customer. So it can help out where cost is an issue for a connection where there is going to be some costly reinforcement. Sometimes the ANM scheme can come in considerably cheaper than that reinforcement. So some of the pros that are associated with ANM I'm not going to run down the whole list that's on screen, but just pick off a couple. With a generation connection, the minimum demand usually occurs only for short periods during the year. So for the remainder of the year, access to the network will be unconstrained. But we'll take a look at this a little bit later in a later slide where I've got some graphical detail that will probably illustrate that point a little bit better. The base scheme itself comes in at about £1 million, but as more entrants come along to the scheme, so it's for multiple customers, not just one-off customers. As more customers come along to the scheme, it gets cheaper overall for the participants in ANM, as the previous connectees get refunds for shared ANM assets that they've already paid for. So some of the kits that we'll come onto on the next slide, I'll tell you which bits are usually shared between customers and which are sole use. So there's something called second comer rules that we have that effectively enable costs to be shared between customers when they're a shared asset. So traditionally it's been used for cables that maybe a couple of, so one customer might pay for a new connection via a cable and they pay for all of that asset, but another customer might come along and use and connect into that cable, and then they pay for a proportion of that cable's cost. So some of the cons associated with the ANM scheme, Northern Powergrid don't currently guarantee a level of network availability, but what we will do is provide an indication of the likely levels of curtailment that you might be exposed to in future, and we'll cover things like outage scenarios, and we'll look at the demand profile on the network and see what kind of curtailment you might be exposed to. We might use some profiles for the type of generation that you're looking to connect, and place that on top of existing demand profiles of circuits that you're going to connect into. At Northern Powergrid we operate what's called a LIFO, which is a last in first out policy. This effectively means that the later entrants to the scheme will be the first to be asked to curtail for a particular constraint. So we go to people in order, if you like. There's a queue position that we maintain that we go to people for a response to first. So just moving on now to some of the ANM building blocks. This is where I'll talk through the scheme that we've got at Driffield, use that as an example for a typical ANM scheme and what the scheme is made up of. So on screen at the moment you've got a schematic diagram of our Driffield network. We've got some transformers there, 3 grid transformers, and there are some circuits on screen, some generators that are connected in at various points on this circuit. So this is a diagram of our Driffield network, simplified. So on this network we have reverse power flow constraints on the 132 to 66 kV grid transformers. That's limited by transformer capacity. We also have some circuit constraints on this bit of the network. So this 66 kV ring system that you can see that's teed off to the Beverley transformer 2. We have some limiting factors on that 66 kV network. So in order to keep power flows within limits on these bits of the network, so on the transformers and on the circuits, we need to install some monitoring equipment, which is on screen now. So we'll look at the critical constraint locations on the network and install the monitoring equipment at those locations. And we've also installed a central controller at our control center, which uses the real-time monitoring information in its network analysis to determine whether any transformers or circuits are approaching the limits of their capability. So this is the central controller, that's one of the big ticket items, if you like, with regards shared costs. We've touched on the monitoring equipment, so the monitoring equipment can be a combination of both shared and sole use, dependent on whether a customer is contributing towards a particular constraint or not. But the central controller is the big ticket item for a shared cost, if you like. So we also have installed some local controllers at each of the generator sites that are contributing to these constraints. These could obviously be demand customers in future. If a customer has some controllable demand, we can use ANM to control that demand too. It doesn't have to be generation that we're controlling. And these monitor, in the Driffield instance, they're monitoring the generator behaviour, and they pass on the target export set points that the central controller back at our control centre sends to them. So they're looking after the generators locally, if you like. We have already got an existing backbone telecoms network between the control centre and our other substations in this area that we can use for ANM purposes. But we also need some last mile telecommunications infrastructure to get from that backbone to the customer sites themselves. So in the main, these are microwave telecoms channels that we've got between customer sites onto the backbone telecommunications system. So telecommunications, then, really that's a key component of the scheme, and it has to be particularly robust considering the real-time nature of the scheme. So really we're talking about passing information from the network all the way back to the control center and then issuing target set points back to the generators, something like every 10 seconds, something like that. So it is real time. The local controllers themselves are obviously their sole use assets funded by the customer in whole. Just moving on to the graphics for the example that I was talking about a little bit earlier. So I've tried to illustrate how the ANM scheme works and what it does to power flows on the network in this example. So firstly, considering this theoretical scenario where we have an annual load profile on an existing overhead line, that's in bright blue, so the graph that you can see in light blue on screen. It already has quite a high proportion of generation connected to it, along with the demand source too. So you can see that the demand on the left hand side, we've got I mean, I've signed MVA negative for power flow in one direction and then positive for power flow in the opposite direction, just to try and illustrate a point with this graphic. So basically we've got power flow in both ways on this circuit at various times throughout. This is a financial year's worth of data that we've got on screen at the moment. And the red line at the bottom there, that's the rating of the overhead line that this power's flowing through. So we've got power flowing backwards and forwards down this overhead line that's rated at 40 MVA. And neither at the top or the bottom at the moment, we're not exceeding the rating of that overhead line. So just moving on. Theoretically, if we had a request for another 10 MVA connection of generation capacity onto this overhead line, we would effectively increase the power flow in one direction, in the exporting direction on this overhead line. So that's basically a shift of that load profile on the overhead line down by another 10 MVA. And you can see there on the graph that at key points throughout the year, at numerous points throughout the year, that we're actually exceeding the rating of that overhead line upwards to nearly 50 MVA on a line that's rated at 40 MVA. So what the ANM scheme does is control that new generation connection, if you like. If it was to join an ANM scheme, the ANM scheme itself would control that generator. It would look at the critical constraint location on the overhead line, run its analysis, and then issue a target set point to that generator to tell that generator how much they could actually export at any one particular time. And the result of that, in this next change, if you just watch the bottom of the graph, you'll be able to see that that's the ANM scheme, which effectively stops the generator exporting at critical times, sort of throttles them back, if you like, and makes sure that the power flow in the overhead line is less than that 40 MVA limit. So we keep things within rating on the network. And the idea here is that the ANM scheme has been a much cheaper option in this case than the uprating and reinforcement of that overhead line itself. So moving on to the Driffield scheme, an update on that. We have basically got pretty much all the infrastructure in place. We've installed the central controller at the control centre, and we've built an interface with our network management system too, to allow our control engineers to have some control over the ANM scheme itself, and to see what is actually going on with the ANM scheme, to view the target set points that are being sent to generators, and to manually intervene as well if there needs to be. All the local controllers have been installed at the remote sites now, and all the monitoring equipment is in place too, barring some final snagging works we've got at a couple of locations. The majority of the last mile comms infrastructure is in place, as I said, which is microwave telecoms in the main. We've completed all the factory acceptance testing. We've been through quite a rigorous procedure with the testing, both at our ANM service providers location and at our control centre too. So we've gone through quite a bit of factory acceptance testing already, which has led to some improvements to the scheme. We've been continuously feeding back and improving as we've gone along. And we're currently in the commissioning phase now. We were due for completion at the end of this month, but we've come across some IT security issues when we've been going through the factory acceptance testing that we're looking into to nail down over the next few weeks. But we're still on track to be operational by the end of Q1 this year. And with that update on the ANM scheme at Driffield, I'll hand back over to David for him to update you on our future plans for ANM.
Okay, thanks very much, Ian. Just looking at the question board, a few questions have come in so far. First of all, I should have mentioned that the slides will be available afterwards. We'll be publishing them on our website, and we'll be sending participants a link to that. So I'm not quite sure how quickly that comes out, but it will be out within, I would have thought, a couple of days. So we've covered that off. Someone asked about the profile of the generator. Ian's chart just showed a continuous additional 10 MVA. We do actually consider the profile of the generator. So if it was a solar farm, clearly they wouldn't be generating at night. So the profile that we would use in the analysis would be on a daytime only basis. But in the initial analysis, if it's a generator that could potentially run at any time, we'd do an initial assessment on its full output, but then actually work with the customer to get a utilisation factor. So wind farms, for example, would only have a certain utilisation factor, and we'd either use some standard data we've got, or we'd use a data set that the customer provides to us. So we can work with both of those. Just moving on then to existing ANM areas. On this graph, you can see that we currently have what we describe as ANM areas in 4 locations. Ian's just talked to you about Driffield, which is the one that's currently being commissioned, and I've called that a standard network, ANM network. And what I mean by that is the solution that we're installing there is what we would describe as business as usual, is a solution that we can implement in other locations as well using a standardized set of equipment. But in the past, we have found ourselves in situations where we needed to do some sort of active control of customers. And we have developed in the past 3 other sort of actively controlled parts of our network. In the Blythe area in Northumberland, we've got 500 megawatts of generation being controlled, where there's a limiting factor of 480 megawatts in the winter on the national grid interface transformers, the supergrid transformers at the grid supply point. But we've also got some limitations on the circuit. So if we lose a circuit, we need to get all the generation in the group down to 240 MVA in the winter, or 220 MVA in the summer. That scheme is very similar in the way it operates to the Driffield scheme that Ian's described, but it's being built on a bespoke basis and therefore is not really very expandable, and it can't give us the additional information about the level of constraints that have occurred across the year, so it doesn't have that historical information being stored in it. The Seal Sands area is just looking after a very small industrial zone, but again, it's got quite a lot of generation in there, about 190 MVA of generation on 2 transformers, and if we lose one transformer, we immediately need to get down to 90 MVA, and that's being managed on an inter-trip type scheme rather than controlling the set point. We actually have to throw generators off in those circumstances. But again, same principles, last in, first off. So there's a sequential tripping scheme there based on the amount of overload that occurs. And then Roos covers a wide area, but is only actually triggered by a single customer, where we have a single customer in a 33 kV circuit with quite a significant amount of generation beyond them, and they are utilising whatever's left in the circuit when the other generators aren't using it. So that really sort of sterilises that area for new entrants, unless we moved to a wider ANM scheme like we're planning to put in at Driffield. So that's what we've got at the moment. And then one of the things that we've committed to doing is to consider new areas for ANM, which would benefit customers. So we're not just going to roll it out everywhere if it's not needed. We want to be able to roll it out in a controlled manner, but we do need to respond to the areas where we're getting tight on the network. So the key considerations for us are, firstly, the amount of contracted and connected. I've written here demand or generation, because an ANM scheme could be associated with an area where we've run out of demand capacity and would have to reinforce to connect more. But primarily, at the moment, the drivers on the network are to do with where we have excess generation rather than excess demand. So This whole presentation is focused towards generation, but the principles that we talk about here can be equally applied. We're looking at the loading on the assets both under intact normal running conditions, but also under outage conditions, whether that's planned outage or due to faults, to ensure that the remaining network doesn't get overloaded if all of the generation is transferred onto a single circuit. We need to bear in mind the cost of a reinforcement solution. So when Ian was talking earlier, he mentioned that the time to use ANM is when the cost of the reinforcement works are disproportionately high compared with the cost of ANM. So we need to understand both the cost of the reinforcement and the cost of implementing ANM, and we need to understand generally the level of curtailment that customers would be suffering and what that potential cost is and how that all comes into the mix to determine whether ANM is a good value solution. And so the level of potential constraints that those new customers are going to see are really important. If the constraints are too severe, customers aren't going to sign up for it. So taking those into consideration, we've analysed across our networks looking for the areas with limited capacity. I'll skip the first point for a second, but the cost of building a new ANM scheme like Driffield is of the order of about £1 million, taking into consideration all the building blocks that Ian's described. And that generally makes it not cost effective for small constraints that may be at a primary substation. Now, the cost of completely rebuilding a primary substation is of the order of about £4 million. But if you've only got a partial constraint within that site, the reinforcement solution will generally be cheaper than that. And the differential in price wouldn't make ANM on its own attractive. But where the cost of the reinforcement is significantly higher than that, then ANM really starts to come into its own. And one of the key areas further up the system where we are seeing constraints is at the interface with National Grid. While we're managing to control the levels of generation on each primary substation and supply point, the cumulative effect of all that is taking us to a point where there's potential constraint points at the National Grid interface in our grid supply points, or GSPs, where we connect into the national transmission network. And that's been the key area that is driving our need to roll ANM out further. Because this is a partially theoretical constraint, because firstly, they generally only occur under outage conditions, and generally it has, and secondly, it has to be at times where there's a lot of generation running and not a lot of demand. The likelihood of the constraint happening is quite low, and that can make it attractive to customers because depending on their financial model, it works for a lot of customers. However, if you're offering a service where you need a guaranteed response, where you have to guarantee a response to someone, then those sorts of connections in ANM areas can prove difficult from a customer's financial model perspective. So the typical cost, I said it's about £1 million to put a scheme in place, but those costs break down, as you can see on the slide here. It's about £350 to £450k to get the central controller installed and all the main control centre interfaces. So that's the main unit, and we think that we need one of those boxes for each grid supply point area that we look at. Now, some of our grid supply points serve vast areas and some serve quite small areas. So we are trying to work out whether one of these boxes could do a couple of small areas or a large and a small area, but we're reasonably confident that it would struggle to do two large areas. The local controllers that we need at the customer sites cost between 40 and 60k, and that includes the development modifications that we have to make to the ANM system to incorporate that customer into the scheme. So that's not all true site-based costs, but they are all the costs associated with getting that new control point in. We've then also got the monitoring points Ian talked about, and they have a similar price to the customer control points, but they can be a little bit more expensive sometimes because Some of our monitoring points are monitoring multiple things within the substation area, so it's a little bit more sometimes than just a single monitoring point. And then the last thing, which is actually one of the things that we find hardest to be certain of at the beginning of a quotation, is the telecommunications to site. Someone's asked us, because Ian mentioned that they are microwave, do they need to be line of sight? And generally, yes, they do. We've got to be able to get that microwave signal through. So the thing that can cause the variation in price here is whether you need a tower and how tall that tower needs to be. We haven't done one yet where we've had to put an intermediate point in between our existing comms network and any of the sites, but we have had to do a couple of sites where they've needed they needed the dish to be quite high. One site, I think we've managed to fit it to the turbine tower.
Turbine tower, yeah. So the only one that we've done, to my knowledge, we've actually got a microwave dish fitted to a wind turbine tower for one of the sites at Driffield. That's the first of its kind in our network area, anyway.
Yeah, and that we obviously need to consider there how far up the tower it needs to be, because it mustn't infringe on the sweep of the blades. So we have to make sure we don't get any interference from that.
Yeah.
So the extra key thing to mention here is that new schemes will only be implemented when a customer actually triggers the need for reinforcement, and ANM is an option, and the customer accepts an ANM contract with us. So we're not going to build these schemes out in advance of need, because that's not considered to be efficient from a regulatory perspective. But once we do trigger that, the build-out time for a new scheme is about 12 to 15 months to include all of the works. However, if you're on an existing location, then we can certainly complete quicker than that. If you're adding to the Driffield scheme. So where are we planning to build out in 2019? We can see the existing areas already here, but a key change here is that the Driffield scheme has got bigger in this map. We are rolling that scheme out to incorporate the whole of the network that is fed from the grid supply point that Driffield's connected to. And because that is the existing Driffield scheme, we can do that without needing a new controller. So the incremental cost to get started on that network will be relatively low. And I'll talk a little bit more about that in a minute. We've also got the area that was labelled as roofs before. We've got additional customers trying to connect into that area now, and as I mentioned earlier, that single customer scheme doesn't really work for multiple customers, so we need to expand that, and we're looking into options to be able to roll that with the Crakey-Beck scheme. And then the next area that is an issue for us is the Keedby area to the south and Grimsby West in the dashed area. The Keedby area is an absolute must for this year, and a little bit more about that in a minute. And the Grimsby West area will only be as and when a customer comes along requiring it. So Driffield expansion, yeah, I've sort of said it before we got to the slide here. So we're going to expand it to cover all of Hull, which was the bit that was missing before, which is the main, actually, from a customer number perspective, is where the majority of the customers fed from that particular grid supply point are. So geographically, you can see on the previous slide that the area had spread towards the southwest, but it was covering the same rural area generally. And because we're going to reuse the existing controller, we're going to save some money there. But Ian mentioned about second comer rules. And new customers going into that network, because they will be utilising the existing equipment that we've put in, will actually be required to make a contribution towards that scheme, and that contribution will be of the order of about 40k per megawatt of ANM export capacity that a customer wants. So you need to bear that in mind. The connection charging regulations actually state exactly how we have to do that, and we're obliged to take that money from the newcomer and actually give a refund to the people who made the initial contributions. and we're obliged to do that for up to 10 years. So anyone connecting to the Driffield network via ANM in the 10-year period from now, because it's about to go live, will be required to make a contribution of that sort of order. So we are currently looking at that scheme to see whether we can roll the Saltend North scheme into it and avoid that central controller cost as well for the Saltend North scheme. We don't know the answer to that question yet.
Quite, no.
But we're looking at it, and we've got our fingers crossed. I wouldn't be saying it if we didn't think there was a reasonable chance. So that's the North Humber. On the South Humber, they are two discrete areas: the Keedby area that I showed on the map, which is the larger area, and the Grimsby West area, which just covers Grimsby, Cleethorpes, and sort of Immingham docks along that coastline. The Keedby area has already been triggered. We've got significant issues at Keedby at the moment where the fault level is exceeded, and therefore customers are now going to have to wait to connect until we've actually replaced the switchboard at that substation, and that work's expected to take about 3.5 years. But those customers, once we've replaced those circuit breakers, will still need ANM to manage the thermal loadings on the network. We looked into whether we could do additional reinforcement to solve that problem, but the additional cost of that wasn't cost effective. So we're moving forward on an ANM basis on the Keedby network, and those customers involved will be getting contacted in the next few months about what work is required. The Grimsby West area is expected to trigger during 2019 based on customer activity that we've seen, and our current position is that we think we'd need a separate controller for that, which would give a delivery time of that scheme of 12 to 15 months from customer acceptance. However, we are looking to see whether we would be able to do that on a single controller as well. I'm less optimistic on that one, but we're going to have a go and see if we can get that to work. So a quick few words about ANM and DSR, so demand side response. There's a lot of talk in the marketplace about demand side response, and it's not a new thing in the sense of customers have been doing demand side response to reduce their output at notified triad peaks on the transmission network to keep their supply costs down over the years. But the distribution network have not particularly been out there looking for demand side response as a service to avoid thermal overloads on the distribution networks. So ANM is all about customers being able to get connected quicker and more cheaply, but as a condition of that cheaper connection, because we've avoided the reinforcement, they agree to reduce their output when necessary, and that's a permanent contractual requirement for the lifetime of their connection. So they need to factor that reduction, and there's no payment made to them for that reduction because they've got the cost saving in the initial connection charge. We don't charge an ANM operating cost. There is an annual operating cost for us to run those schemes, but that is rolled into our normal operating costs. For demand side response, this is more about where the background level of demand on the network has grown over time. All our customers are operating within their agreed capacities, but customers are using more of that agreed capacity over time, and we eventually reach a point where the potential overload on the network is not attributable to any single customer asking for more, and under those circumstances we need to solve that problem at our cost. So we would be going out for competitive tender for fixed term contracts to provide some sort of DSR solution as and when that condition occurs. And there are a number of ways in which we can do that in terms of how the service works, but the capital cost and the operating costs associated with that DSR scheme would be paid for by Northern Powergrid. And the way we would justify that cost is we would be saving customers money because we would be doing that instead of more expensive reinforcement. So the concept of how an ANM scheme could work are quite similar to having what I would call a complex demand-side response scheme. So the monitoring points that we need to understand when the overloads might occur and the control points we might need could be quite similar. But that DSR doesn't need to be that complex. There could be simpler DSR schemes where simply we agree with the customer that on certain days of the week or certain times of year they operate with a lower output. That doesn't require any active control from us. We just are looking for an operating regime with the customer. It could be something where we get a response from the customer where we ring them up and say, look, within 3 hours you need to reduce. So there are cheaper ways to do it, but DSR has the potential to build off the back of ANM if we do need a wider area scheme that's controlling large customers. So we think we could adapt if we needed to the ANM type solutions we've got and use those to support a DSR scheme where we were looking for significant control of big customers, but probably not so much for small customers. Okay, so that brings us to the end of the main presentation. We've got the opportunity for some questions and answers, and Ian's been keeping an eye on the questions that are coming in. But before we move to that, it would just be helpful for us to understand whether what we've taken you through today, recognising we haven't done the Q&A yet, but we will do our best to answer those. Whether the presentation's been useful for you, and this is good feedback for our customer-facing teams who are trying to make sure that we're telling you about what's going on and that there's an understanding out there. So if you're able to, if you could just give us a view on whether it's been useful to you. I'll just leave that running in the background. I'm not going to end the poll, so you don't have to answer it now, but we'll move on while that's running. I've got a few more bits and pieces to say. So in terms of opportunities for engagement, we've got a number of other webinars coming up in the next couple of months, starting with one about assessment and design fees at the end of this month. Then I'm going to be talking more about statement of works, and that's the interaction between us and National Grid in March. And then we've got the DG Owner Operator Forum. So if you are a DG Owner Operator in our area and you want to talk to us about issues on a day-to-day basis for your existing plants, that's on the 20th of March. And then we have our 6-monthly Customer Connections Forum in April, which is normally in York, where again we share information on what's going on in the industry, and you've got the opportunity to come and talk to us. On top of all that, we have our normal customer connection surgeries on a monthly basis, and you can get into those. You can book all those activities using the links that you can see here. If you've got any specific questions about a particular connection, new connection, then our commercial engineers and design engineers, their details are also on our website. So you can say, I've got a job in York. You can find out who covers the York area and get some information on that, and talk directly to a commercial or a design engineer. Okay, so questions and answers, Ian.
Yeah. So while David's been talking, I've been keeping an eye on the questions that have been coming in. It looks like there are a handful for me and one for you, David. So
okay.
I'll start with them in order. So we had a question earlier on that was related to slide 7, the graphical.
Oh yeah, okay.
The substation demand profile and the overhead line that I put up on screen earlier on. The question was, has any consideration been made for adding flexibility on the line rating side? Well, for the Driffield scheme, we have done effectively. So we have applied seasonal ratings to the overhead line, and that's built into the scheme itself. So on season change, the rating for the overhead line changes automatically, and we start curtailing to the revised line rating dependent on what season we're running in. We haven't got any sort of active line monitoring, real-time thermal rating equipment associated with that overhead line yet, but for that entire ring system that you saw earlier on, we have got seasonal ratings applied to that.
So correct me if I'm wrong, Ian. The ANM scheme, if we wanted to take inputs of weather, we think we've got the capability to develop that so that we could make the ratings of lines more active.
Yeah, so we have got that capability. We can take those inputs and inform real-time thermal ratings, but for the time being, we're just keeping things simple to get that learning into the business first before we sort of move on to the next thing.
So the red line on this slide would move down.
It would move down and up.
It would go lower in the summer and higher in the winter.
It would, yes.
Yeah.
Okay. Another one. What are the typical bandwidth requirements for ANM that are driving point-to-point microwave systems? So typically at Driffield we're needing 64 to 128k kilobits per second for the comms infrastructure from each site onto the backbone. We did some trials with radio technology up to sort of 40 kilobytes per second, but the trials that we did, which were just bench tests, didn't prove successful really at all. So that pointed us in the direction of the microwave comms for the scheme that we've got at Driffield. One question for you, Dave.
Yeah.
When does the 10-year clock start ticking for the second comer rule?
Okay, so this is testing my knowledge of the Act. I'm pretty sure it's from the date of connection of the first customer. So some of the customers in this network are already connected, but I think we will probably base it on when they get connected in an ANM format. So I think that will be in March when you do final commissioning.
Yeah.
We'll have to go away and confirm that, but I'm pretty sure that's when it starts.
Yeah. So one note that we've received is just to state that an indication of the nature of the constraints and the likely curtailment forecasts as granular as possible, and an indication of the capacity to be released by ANM would be hugely useful. So just to let you know that Northern Powergrid will provide a curtailment assessment as part of the ANM offer, if you like. So we'll give you an indication of the likely megawatt hours that you might lose by connecting for an ANM connection, and we'll obviously give you an indication of how much it would cost for the more traditional connection, where you'd have unlimited access to the network, outages aside, so that you can sort of do your own due diligence as well, and make sure that the connection stacks up for you. Of course, there are no guarantees that the analysis that we provide you with is how things will turn out. We'd expect you to do your own due diligence and figure out whether the connection's financially viable for yourself.
Just on that point, Ian, we'd also give the customer the historical half-hourly data on our network, so that you can do your own due diligence and do exactly the same analysis that we've done. And we'll either work with your profile data or with a so-called standard set. So, you've got the options to be able to see what that level of curtailment is likely to be.
Yeah.
Yeah. Okay.
Just one more question that's come in. For DSR, for an existing connected demand customer, could the existing infrastructure, e.g. the existing pilots, be used to provide the required signalling rather than installing new infrastructure? So I guess if the existing infrastructure is capable and has the associated capacity that could lend itself to providing a DSR service, I don't see why we wouldn't use that for an existing connected customer. There's no point in installing additional assets if we can use what we've already got.
Yeah. So on the building blocks slide here, you can see on here Ian talked about the existing backbone communications. That's exactly what we've done for building the ANM.
Yeah.
Is we've said, look, we've got kit that can do this already. In the same way, whether it's the monitoring points or the comms again or anything else, any kit that we can utilise to drive a different solution, we would do so. The way it's monitoring is such a way that we could pull that signal off and use it for something else if we needed to.
That's right, yeah. So okay. Those are all the questions that we had in today, so we've managed to get through them all, which is good.
Okay. So in that case, I will just end the poll so that people can see the results of what we've had there. Actually, we can't see the results until we press the button, so I've pressed the button now, and well, that's very reassuring to know that everyone who's responded, I should say,
yeah.
has found it to be informative. So thank you for that. If you do have any other questions, you think of them after we've closed the webinar in a few seconds, then just fire them through to that initial email, ICE at northernpowergrid.com. Emma, who is our ICE coordinator, will fire those through to us, and we'll do our best to respond to you directly. But as I said before, if you've got any specific inquiries about a specific connection, then please do contact the design engineers or the commercial engineers, and they'll be able to help you out on the detail of what you need for that specific site. So, has anything else come in the last few seconds?
We've just had one more question that's come in. So just a note saying that the curtailment information sounds like it's a good idea. Would a high-level simple percentage be available before a connection offer is received? Spending a lot on an offer to find the curtailment is unviably high is not a preferable method. So
okay, well, there's two elements to that, isn't there? So if you're the first customer to develop on a network, you've probably already you probably haven't found out that you need ANM until you've got to the stage of asking us for a quote. In which case, we won't. If that's the first one, we won't have done a curtailment estimate at that time, but we will have some half-hourly data that we could give you some indication from. If you're trying to get into a network that already exists, because we've done curtailment estimates for other customers, if your technology is of a similar kind, then we can probably give you a very good indication without us actually having to dive in and try and do that detailed assessment. So the level of detail we can give you beforehand will vary, but I think, we recognise that that customers don't want to commit massively before getting that information. But there is a cost associated with us doing any sort of assessment, and I think you have to recognise that the assessment and design fees are there to capture that. If you're opening in a new area, that's where it's a bit more tricky.
Yeah, I'd agree with that, David.
Okay.
That's it. We don't have any more questions that have come through since.
Okay. Right. Well, we appreciate your participation. Thank you for joining us today, and we look forward to you joining us again on another occasion. Thanks and bye.